1.10 to 1.16. Which of the following are properties of the image of an extended object formed in a plane mirror? So let's see our options. The first one is laterally inverted. Okay, let's say you're looking at yourself in a mirror. Now, here we're only going to talk about the reflection because it said object formed in a plane mirror. So let's say you raise your right hand. Your reflection would raise its left hand because you are inverted. That means you are flipped. So that's why it's laterally inverted. Behind the mirror. Your reflection itself is behind the mirror. Like, it's not in front of the mirror. It's not on the mirror. Like, now if it was in front of the mirror, the reflection could literally crawl out and, like, I don't know, eat you. But, like, it's obviously not possible. So it's behind the mirror. Point image. That point image means that your reflection is at a single point, which is wrong, because if your reflection was at a single point, your reflection wouldn't even move with you. But if you spin around, your reflection would spin around as well. So your reflection is extended. They even say it in the question, an extended object. So point image is wrong. Enlarged. No, your reflection is literally reflecting you. It's the exact same as you. So this is also incorrect. Virtual. This is correct because when your reflection is called a virtual image. That's just like what it's called. Which of the following are optical instruments that contain plane mirrors? A kaleidoscope. Yes, a kaleidoscope uses 3 plane mirrors connected to a triangular tube to form like symmetrical patterns. Like, let me show you. This is something like what a kaleidoscope would produce. As you can see, it's symmetrical patterns just reflected off of multiple mirrors. Okay, a periscope. Yes, a periscope uses 2 plane mirrors that are parallel to each other, and they're tilted at a 45-degree angle so that they reflect each other on such a way to produce like a very sharp image, so you can see what's happening like better. And this is often used in like submarines, like, you know, the part that goes above the water, so you can see like what's happening above water while the actual submarine itself is like under. So these are correct. A laser, yes. A laser uses like 2 mirrors to amplify the light in like one direction, like in one specific point, to make it like very strong. So lasers. Magnifiers are wrong. They use magnifiers. They use a sorry, I meant they use a single convex lens, so not a plane mirror. And binoculars use a series of prisms to zoom into an image. Which of the following devices use a plane mirror? So we already said kaleidoscopes use a plane mirror, and we also already said lasers use a plane mirror. So we know those two. And yeah, that's it. Submarines use a device to view from a submerged position warships above sea level. What is this device called? We already said it's called periscopes because they use 245-degree angled plane mirrors. The non-magnifying version of this device is made of 2. So we said, so they said the non-magnifying version of this device, so they're referring to the periscope. So I already said that the periscope has 2 parallel plane mirrors, and I already said that they made an angle of 45 degrees. The first mirror forms, of course, if it's forming, like if the mirror is forming, that means a reflection, which means a virtual image. And the second mirror forms another virtual image, which is at the same horizontal level as the observer. What conclusion can be drawn from the pin method? So it's very difficult to explain the pin method. The easiest way is just to watch a video on how the pin method works, and you'd understand better. But basically, you take 2 pins and a ray of light reflects on one pin, and then you look at another pin from the under it all, and you'll see that both the pins kind of line up, which proves that the incident ray, the reflected ray, and the normal all lie at the point of incidence, all lie on the same plane. and the angle of incidence is equal to the angle of reflection. Which of the following equipment are required to determine the position of the image of a pin in a plane mirror? So this one, guys, it's really important that you learn the verifying of reflection. So you're going to need a plane mirror with a straight edge, 5 pins, a sharp pencil, and a ruler. This one's just like, you have to learn it. Complete the diagram to show the correct image of I, of object O, formed in the plane mirror of M. So if it's a mirror, that means it's going to reflect. So it's just going to be the same thing, just going in the opposite direction because it is laterally inverted. The blank states that the angle of incidence is equal to the angle of reflection. This is the first law of reflection, my bad. This one, again, you have to memorize the laws of reflection. The blank states that the angle of incidence is equal to the angle of reflection. The second law of reflection states that you have to memorize the laws of reflection. Consider the path of ray of light striking the mirror at M. Striking a mirror M at 51 degrees with the plane of the mirror. The angle of reflection of mirror M is... Okay, so let's just really quickly see our normal, which goes across the center here. Now this is like the ray of light, and like if it's gonna be reflected, that means we're gonna just copy it here. And this is also gonna be 51 because it's reflected. But now they want the angle of reflection, which is here. So if we know that from the normal to the boundary it's perpendicular, so it's 90 degrees. And if this is 51, you do 90 minus 51 and you should get your answer, which is 39. Okay, so select a diagram which shows an experimental demonstration of the refraction of light. Okay, so the first image is of diffuse reflection, which usually happens on a rough surface and the light is scattered everywhere and it's not neat. The second one is of, to my understanding, a bunch of like opaque pieces of like something, and there's a candle flame over there, so it's not refraction. The third one is of reflection. The fourth one, which is the most common example, you learned this in like grade 3, of refraction. The refractive index of a quartz crystal is 1.5. The speed of light in a vacuum is 3 times 10 to the power of 8 meters per second. Then the speed of light in quartz is blank times 10 to the power of 8. Okay, so this one is actually the first formula we ever learned. So it's index of refraction equals speed of light in speed of light in a vacuum and over speed of light in another medium. Now the speed of light in vacuum is always going to be equal to 3 times 10 to the power of 8. You have to memorize this. So now applying the formula, we have the index of refraction, which is 1.5, equals 3 times 10 to the power of 8 over V, which is what we need to find. So now we just solve it and you get 2 times 10 to the power of 8. The angle of reflection at which the reflected ray bounces off plate 2 is... The diagram below shows a ray of light incident on a system of smooth metal plates. The angle of reflection at which the reflected ray bounces off plate 2 is blank degrees. So for this question, we're going to just start by drawing the reflected ray, which goes from here to here. And we know that since it's reflected, this is also going to be 40 degrees, right? And we also know that this is perpendicular and we need to find this angle, which is x. So if this is perpendicular, that means it's 90. Now to get the angle, we need to do 90 minus 40, which you get 50. So that's hold on. That's this one, 50. And this is going to be 70. Now, of course, if we just need to get x, we do 180, because sum of all angles in a triangle, so 180 minus 70 minus 50, you get 60, and that's your answer. It's very simple once you know how to solve it. An incident ray of light is reflected twice from two flat perpendicular mirrors as shown in the figure below. The value of x is, using the first law of reflection, the value of x is going to be 30. Also, just if it's reflecting, it's of course obviously going to be 30. The value of angle y. So we know that x is 30, right? Meaning that when it hits the boundary, it's going to be hitting at an angle of 30. So if we know x is 30, and if it's hitting at an angle of 30, means, and we know it's perpendicular as they show us, you do 90. Oh, by the way, why is the whole thing? So you do 90 minus 30. Oh, sorry, so they were perpendicular. So you do 90 minus 30 and you get 60, and that's just for 1/2 of y. So you have to get 60 on the other side as well. So you do 60 plus 60 and you should get 120, which is the value of y. At which labeled position is the image of the object formed? So we can see that the eye is looking directly, and of course the object is always formed behind the plane mirror, meaning it can either be B or C. Of course it's going to be, now following the path of the eye, it's of course obviously going to be C. So like, of course when you look at an object, you're not going to like see an object that's to the right of you, that in a mirror. That doesn't make any sense. Consider the ray diagram below that shows the reflection of the parallel beam on a certain surface. The parallel beam is incident at point A or B. So one thing you should know is that there are two types of reflections. So there is specular reflection, which looks pretty neat. So it's like that. Sorry, it's not coming out good when I'm trying to draw it. But it's usually on a smooth surface. That's specular reflection. And there's diffuse reflection, which is kind of messy as a way to put it. So the light doesn't like reflect exactly, kind of is scattered around all directions, and it usually happens on a rough surface. So the blue is an example of diffuse reflection. So the above diagram is an example of a blank reflection. As we can see, it's not quite as perfect or neat as a diffuser, like as a specular reflection. It's kind of going wider, so it's diffuse reflection. The line A prime, so we know, of course, that is the normal. That should be something you know. It's part of the diagram, you should memorize it. And the surface S prime. A light ray hits a plane mirror at an angle of incidence 0 degrees. What would then happen to the light ray? So here we're talking about reflection, not refraction. So the normal, so if it's reflecting like this, so on the normal like 0 degrees, then its reflected ray is also going to be like straight, like that. So it's also going to be 0 degrees. So it will reflect back on itself with an angle of reflection of 0 degrees. A passenger looking in the rearview mirror of a cab sees the eyes of a driver. Does the driver see the passenger's eyes when he looks in the mirror? Okay, so when you look at yourself in the mirror and then someone stands behind you, they can see you in the mirror as well as themselves. So it's kind of like reversible. Or like even when you put like, you know, when you try to see like the back of your head, so then you pull out like another mirror, you put it in front of you, and then you can see like the back of your hair in your phone mirror because that mirror is reflecting off of the mirror you're holding. Do you know what I'm talking about? That's because of the principle of reversibility. The speed of light in a vacuum, in scientific notation to one significant figure. This one you have to learn it. It's 3 times 10 to the power of 8. What are factors that determine the refraction taking place in a glass of water? Okay, so what is refraction? It's the bending of light. Can the color affect the bending of light? Of course not, it can't affect how the light bends. But the initial ray that hits the glass can, so the angle of incidence can. The volume does not affect it. The thickness of the pencil cannot affect the bending of light. But the change in the index of refraction between the media can affect. The medium, though the index refraction of a diamond is 2.42, and that of water is 1.33. The medium that is more refractive is the diamond. This one's obvious, the number is bigger than the water, and because it has a higher index of refraction. The speed of light in diamond to 2 decimal places is blank times 10 to the power of 8. So we're going to use the formula which I mentioned before. So the index of refraction is 2.42. That equals 3 times 10 to the power of 8 over volume. So you should put that into your calculator and you should get 1.24, and you do the same thing for water. So 1.33 equals 3 times 10 to the power of 8 over V, and you should get 2.26.